the percentage of wins and the percentage of losses. Both sides have to be greater than 15, right? So both sides have to be greater than 15. So now for starters, let's get our calculator up. Okay, so are both sides really greater than 15? So we got 64 games. 64 games times 0.58. Okay, that represents 37 games. That's fine. We're good there. Okay, now out of the 64 games, and that would leave 37, and that would mean that's 37 wins, and that's 23 losses. So we're good on both sides there. How about on the 65%? 65% of 64 games, clear. 64 games. Actually, I didn't even have to do the regular season. I only had to do the playoffs because that's really the regular season is just a known p-value, right? The playoffs are the ones that's really the sample of 64. So I just sort of started with that. 64 games. There were 65% of those were wins times 65% were wins times 0.65. Oops. 64 games times 0.65 is equal to, so that's 41 wins or 42 wins, leaving 18 losses. So both sides of that, in other words, both sides of this possibility, this 65%, the sample, in other words, that 65% out of 64 games represents 42 wins and 18 losses for the home team, right? Or whatever, 64 minus 42 is 22 losses for the home team. So both sides of that, successes and losses, successes and non-successes, both sides of that proportion are greater than 15. Imagine had this been 90% of the time, well, 90% would have left only 10% losses, right? And 10% non-successes. That would only be 6 games. We wouldn't be satisfying our sample size. I chose just right. Oh, the 90% was based on the fact. I'm not sure, Catherine. You mean 90% when I just mentioned it now? If this had been 90% or 90% in terms of what the z-score would have been if I looked it up on a table. In this case, I'm talking about the 90% here. So we have to make sure we satisfy that qualification. Oh, in terms of the z-score, I chose 90% before because, okay, if I'm going to look this up on a standard z-table, I just said, okay, well, I need a z-score that represents 95% to the left of this value. Okay, I could look that up on the z-table, and on our z-table, all I have to do is find the area of 95%. It'll give me a z-score of 1.64 plus 1.64. If I had a table that only gave me two-sided values, well then this number 1.64 is the same number that I would get if I were looking for a confidence interval of 90% instead of 95%, because a two-sided value to get this z-score would have to be 5% on this side, 5% on that side, so I'd be looking for 90%. I wouldn't worry about that. That's really kind of a side issue. Most of the time, that's not even going to come up, I don't think. Just remember that you need that whole 5% on one side when you do a single-sided test, and you only need less rigorous tests. Now our critical value is only 1.64. Okay, so let's go ahead and do this. So the way we're going to do this is our z-score or t-score. In this case, is going to be a z-score almost always with it's going to be almost always a z-score with proportions, because our sample size is always going to be over 30 because both sides have to be over 15. Yeses and nos have to be over 15 in any proportion we're working with as part of our assumptions. So z is going to be equal to p cap, in other words, or p hat, whichever one you want to call it, minus the proportion, the true proportion for the season, right? We've got to make sure that those are 2 standard deviations apart. And how do we do proportions for standard deviations? Anybody want to hazard a guess on that? Right, remember? Is it, right, the difference? Okay, P, right, P, whoops, P we're going to get it. I'm going to talk about how we're going to choose which one of these we're going to use. P, P times 1 minus P over the square root, over N, and we're going to take the square root of this whole thing. Okay? Had a senior moment there, forgot about the square root. We're going to take the square root of this whole thing. We put another parentheses in here just so it looks a little bit better. Okay, so that's going to be our standard error. Okay, so now, which one of these two P's should I choose? Anyone who has a guess, should I choose the 58% or should I choose the 65%? Okay, let's get a couple of opinions here. 55, 68, or 55%. Well, you could make kind of an argument for either one of them. By the way, I'm getting almost 50% I'm getting almost 50% on the results on that question. I'm glad because it's an interesting issue. Okay, remember when we do these kinds of tests, the way statisticians work, which is different than a lot of ways that the rest of the world works, is that they always start off assuming that the null hypothesis is true, that there's no difference between these results, and that it's incumbent on us to prove that there really is a difference. Okay, so using that logic, you would use the proportion for the playoffs and the regular season. Okay, the population that you know about. Okay, so now and you would choose two of these things. Now, if you had two proportions, it gets more complicated. If you have two proportions, you have to make a decision about how you're going to do it. And typically, what you do is you combine the two groups. Like if you were comparing a sample of 64 you took a sample of 64 regular season games and 64 playoff games, and you wanted to compare the two of them. Well, then to calculate the standard error, you would kind of do a weighted average of the two proportions. And we're going to talk about that, like how that kind of stuff happens in just a little while. But for right now, when we're doing a single-sided sample, typically you would use the null hypothesis. In other words, the regular season, the one you know, the number you're comparing it to, the population that you're trying to prove that it's different than. Okay, so that's going to be 58%. Okay, now if I wanted to be really conservative, and a lot of times you'll see this, you might have noticed that in the margin of error, when they needed to use a standard deviation to calculate the margin of error for that political poll, they didn't use either one. They didn't use one groups and other groups, lowest guys, the highest guys, right? They didn't use any of those things. They used a very conservative version of this. What did they use there? You guys remember? Right? They used 50%. Why did they use 50%? They used 50%, right? Thank you, friends. They used 50% because this number is the largest when the p-value is 50%. 0.5 times 1 minus p is 0.5. 0.5 times 0.5 is 0.25. Any other value for p is going to be small, is going to make that number smaller, which means that you divide by a smaller number, which means that it makes your z-score bigger. It makes it more likely you're going to reject your null hypothesis. So if you make this a big number, it makes it less likely that you'll have a big z-score and reject your null hypothesis, which means that it forces you to have more proof. So that's what makes it a more conservative approach. So if, for instance, if this were 0.1, 0.1 times 0.9 would be 0.09, right? If this were 0.6, 0.6 times 0.4 would be 0.24, less than the 0.25, right? So in any case, 0.5 times 0.5, if you're really stuck, you could use, and you're not sure which to use, and they're close, and so on, you want to really be conservative, you could always use 0.5. But in this case, the best possibility is to use 0.58. Is everybody comfortable with that? I could see you arguing that, well, you really don't know, and who knows how many regular season games there were. It doesn't say here. It could have been maybe a strike shortened season. There were only 12 games. Who knows? So you might have been tempted to use the 0.65 that you actually know, right, rather than being told from some other source. But that's typically the way that you really should approach that. Okay, so that like everything you before you do the calculation, everything is based on a null, and as you do the calculation, you're comparing your results to it. Okay, so I hope that helps out, clarifies that a little bit. I was hoping that that example, that little odd example with the, and that you saw them use 0.5 in that particular example, because they wanted to be conservative with the margin of error, because when they do polls like that, they look like fools half the time anyway when it comes out wrong. So they want to reduce the likelihood of being criticized. And during the last election, there was an enormous amount of criticism for the Republican pollsters, because the pollsters that the Republicans were using to decide where to spend their money, what states to spend their money, and what platforms to put out, and so on and so forth, because their polls on election night were so different than what the results were, and obviously, so in the wrong direction for them. Okay, so you want to be conservative with those things when you can, and most conservative would be to just assume it's what it was in a regular season, because you're trying to prove the opposite anyway. Okay, so now let's actually work this out, see what we get. Okay, where's Excel? Okay, so P during regular playoffs, P cap now is 0.65. This is 0.58. Okay, and our standard error, what's it going to be equal to? That's going to be equal to, it's going to be equal to the square root of, I'm kind of abbreviating this now because by this time you've seen me do this many times, so I'm not laying it out, and we don't have that much time anyway. So 0.65, right, times 1 minus 0.65. Okay, and I'm going to put that into parentheses right now. And should I put I'm going to have to put this in parentheses also. Okay, so I got that square root divided by n, which is n is still 64. Okay, so this is gonna do the subtraction first and the multiplication and division. This should work. And our standard error. Remember, that's our standard error. That's our standard error. This is our p-value for the population, and this is our p-hat or p-cat, whichever one you like to use. So the difference, our z-score, in this case, is going to be equal to p. Oh, I'm going to use the larger number just so we don't get negatives. That minus this over this. Let me put this in parentheses so it does the subtraction before it does the division. And I get a z-score of 1.17. What was our critical z-score again? Since this is a one-sided test, our critical z-score was 1.64. What are my conclusions now? Oh, yeah. Oh, my goodness. What did I use? Oh, my goodness. Geez, I'm really what did I use here? I used C2, which is, oh, you're absolutely right. I can't believe I did that. I went through a 20-minute argument on what, use the other one. I just used the wrong one. Can't believe I did that. I just saw a movie on Moms Mabley. Any of you guys know who Moms Mabley was? Okay, let's see what this comes out to. This comes out to, is it there? Over C5. Did that change? I think it did change, right? It went down a little bit, right? So we're going to come to the same conclusion. Fortunately for me, do you guys know who Moms Mabley is? Anybody there know who Moms Mabley is at all?